Hi, this is Michael Emmerine, and this session will be discussing how decouplers work. Just a few points that we're going to cover on this, and it's the 4 items that you see here. I'll give you a little history about Dairyland, then what do decouplers actually do, how those function, and what are the features of the Dairyland decoupler, and then some brief applications to show you where you might see decouplers. So a little history about the Dairyland beginning. I'm going to stop on that one. I'll get it. Hang in there. So the history of Dairyland begins back in 1983 when Henry Tochik was asked to solve a problem with stray voltage at dairy farms. That was the inception of our company, and from there you can see that we have developed into different products, and that timeline shows you that in the 90s we first introduced what is called the PCR, the polarization cell replacement decoupler, and that began with our device for the corrosion industry. In 2000 we began marketing and selling worldwide for solid-state decouplers, and that reached thousands of units going worldwide, to the point that in 2005 we developed the decoupler to launch our new device called the SSD, the solid-state decoupler, and that was allowing other markets and other parts of the industry to also use our decoupler for applications. Dairyland recognizes that becoming certified with our products is important, but it's also important to show that the company is a certified company, meaning that every level of our company, from design, engineering, manufacturing, customer support, and technical support, is all following a certain standard. So in 2012, we became an ISO 9001 certified company, and we continue that practice to today. To the point that in 2019, we are a strong certified company within the organization and for the products that we design and manufacture. What does our decoupler actually do? We have a high resistance to cathodic protection current. That's the DC current. We don't touch the cathodic protection current. We have a low resistance in our decouplers to frequencies that are 50 and 60 hertz and other higher signals to allow those frequencies to go through our device to the grounding system. So induced AC and AC faults, and as you'll find out, lightning, will go through our device safely, collapse that AC voltage, and run it through our device to the grounding system. That is, as you just heard, a very safe feature of our device for the technicians working on the system and for any other types of electrical equipment that might be on the pipeline system. So it allows that AC, induced AC, to go through our device to the grounding system. And what about lightning or AC faults? It also allows lightning to pass through the decoupler to the ground for safety. Since the Dairyland decoupler is not touching the DC current, that's the cathodic protection current, and it does allow that induced AC or an AC fault or a lightning event to pass through the Dairyland decoupler to the grounding system. That's all safety. Again, we're not touching that CP current. That means that a technician would see an optimization of their CP system because we're not touching that DC current. The induced AC that is out there on the system is mitigated, and that is what the company most likely is after, is to mitigate any AC that's appearing on their system. It's protecting the technicians as well as electrical equipment. That's the safety first idea that Dairyland has, that is also being looked at by a pipeline company to be safe with the technicians and safe for any electrical equipment. This is a pretty good example of what's existing in the real world. The corridors being shared by a pipeline company as well as a high voltage power line. So if the pipeline exists, doesn't matter what came first, is it the pipeline or the power lines, it doesn't matter. They're all in the same corridor. And this pipeline has actually got a couple of features that is very prominent. There's a rectifier that's supplying cathodic protection to an anode bed, and that is protecting the pipeline. That's the engineering feature that's supplying the cathodic protection, the DC current to the pipeline. But the company has decided that there should be some mitigation of AC, and that's normal. They will attach or lay down a copper or a zinc ribbon, and that's draining off, you might say, any AC that's existing on the pipeline. But there's a problem in that, in the fact that not only is the anode bed, the cathodic protection current being supplied from the rectifier to the anode bed, it's supposed to protect just the pipeline, but because of this structure and the different metals that are now in the earth, the cathodic protection is now trying to be supplied to everything that's there, the pipeline and the zinc or copper ribbon that's laid down. So the efficiency of that system is no longer there. It can't protect everything efficiently. There's where the Dairyland decoupler comes in play. So you see those green devices on either side of the rectifier. That is a pedestal, and inside of that is a decoupler. We allow that AC to go through our device to the grounding system by attaching a wire from the pipeline to the negative lug of the decoupler, and then the positive lug would go to the grounding system. So what's happening is that AC is being mitigated through our decoupler to that grounding system safely, and it allows the cathodic protection, the DC current, to stay just where it was designed to stay, which is on that pipeline. So the technician and the pipeline company would see an optimization of their CP current. These are the features that come with every decoupler. Just go through them real quickly. The decoupler itself was a fail-safe design. It assures that there's safety to the grounding system under any condition that might exist. Lightning, AC surge. It is a maintenance-free. It's a solid-state design. There's no parts that need to be maintained. There's no fluid-filled anything. It is a maintenance-free, solid-state design. The performance of this product, of all of our decouplers, are proven over time to be a very, very low fail rate. As you can see for this solid-state decoupler, it is less than 1%. Actually down to the 0.001% of a fail rate. If there's any certification need for, say, Class 1 Div 1 or Class 1 Div 2, and I should mention that outside the United States, that would be Class 1 Zone 1 or Class 1 Zone 2, or non-hazardous locations, we have those certification for that type of location. As mentioned in the first slide or two, Dairyland has made a consistent effort to become an ISO 9001 certified company in the areas of our engineering, manufacturing, and all the way through our service teams and support teams to show not only the consistent quality of the product itself, but the consistent quality and service to the clients that might call in for pricing and for help on technical issues. This slide is showing you a breakdown of what the model might look like as far as the label that you would see on the decoupler. Just a couple of items to point out here. Whatever decoupler you receive, the first portion of that model rating will tell you what the decoupler is. In this example, it's the SSD. It could be starting with a PCR or an OVP. So running with this example, this is an SSD, and then we have a dash. That's actually a -2/2. That tells us our blocking threshold for the DC side of the rating. So this is a -2 + 2. The polarities are equal in this. It could be a -3/+1. And there's different applications that would take either type of polarity. The next dash that you see tells us about the AC fault current. An SSD itself, as you can see down below, the AC fault current ratings talk about the fault levels going from 1.2 to 5 kA. This example is a 3.7 kA AC fault current rating. So the next dash is showing a 100, and that's pointing to the lightning surge current. That's rated in kA. So for the models, in this case it's an SSD, for the models that are a 2, a 3.7, and a 5 kA, all of those would be 100 kA crest at an 8/20 microseconds waveform. If you had chosen a 1.2, or your model shows a 1.2 kA model, then that is a 75 kA crest at 8/20 microseconds. Just a side note, if this was a PCR model, all of those models are a 100 kA crest at an 8/20 microsecond waveform. The next dash is telling us about the terminal arrangement. Most normal PCRs and SSDs would come with a side-by-side standard terminal arrangement. Then you would see that letter R in the model number. If the letter R is not in the model number here, that just signifies that the client has asked us to mount those terminals front to back, so they'd be in a different arrangement. So in this case, the example is showing the normal arrangement, the standard for a side-to-side terminal arrangement. The last piece on that model number is showing EAC, and it's the certification system. So one of the questions that an application engineer might ask you is, tell me about the location's hazardous rating, and what do you need for, what type of rating do you need for the location where this decoupler would be sitting. So is it class 1 div 1 or zone 1, or class 1 div 2, zone 2, or non-hazardous? And is it an international industrial certification needed, and so forth? So those are the classifications that we would be asking about. The next piece here is, how do you choose that decoupler? Well, there's a couple of questions that you need to be asked, or you can ask yourself when deciding on the decoupler. The first one there is about the AC. Is there AC present? If there is, then you're looking at a true decoupler. Now, I'll get to the types of models that we're looking at here shortly, but that's the first question to think about. Is AC present? And let's stop on that a second and think about the AC itself. You might not know, but if there is, say, power lines in the area, then that's telling you that there truly is induced AC that could go onto that pipeline system or onto the structure, and we would need to know that. And it doesn't matter what level of AC, it's the answer to the question, is induced AC present or is AC present, is yes. Then you need a true decoupler. If AC is not present or never will be, then we could help you look at the line called the OVP, the over voltage protectors. And there's two of those, either the OVP itself or the OVP2. So the second set of questions is telling me about the classification for that area or that location. Is it a Class 1 Div 1 or Zone 1 outside the United States? Is it a Class 1 Div 2 or Zone 2, again outside the United States? Or is it non-hazardous? We would need to know that to help you get to the right decoupler as well. So taking that Class 1 Div 1 or Zone 1 location, and if there's no AC present and never will be, then you could look at an OVP. That's an over voltage protector. It has the casing for hazardous locations, and that would be that second column with the OVP. If any level of AC is present and it's a Class 1 Div 1 or Zone 1 location, then you truly need a PCR-H. That's a polarization cell replacement for hazardous location. That's the decoupler that is needed at that location. Back to the type of classification, if you tell us it's a non-hazardous or it's a Class 1 Div 2 or Zone 2 location, and there is no AC present and never will be, then you could look at the OVP2 device. If any level of AC is present at that location and it's Class 1 Div 2 or Zone 2 or non-hazardous, then there's two decouplers that you could choose from, either the SSD or the PCR. And at that point we would need to find out what the AC fault rating is at the location so we could get you to the right product. So those are the two types of questions. Know your AC, is there any present, any level, and what is the hazardous classification rating. Just a few pictures to show you the typical installs that might be used for the devices that we manufacture and sell. The one on the far left is for isolation joint protection, as it states. That's an SSD for the isolation joint. We would have the brackets that you could attach across that joint. We would need a few other items in there, the ANSI rating and the size bolts and so forth, but that's one of the applications for an SSD across isolation joints. The picture in the middle is a PCR inside of a pedestal. You can see the culprit in the background. I guess I could say at this quarter there is induced AC most definitely present. So the company's probably using this for AC mitigation purposes, and they're attaching that PCR to the pipeline to mitigate the AC to the grounding system. The third picture that you see here is a PCR that's installed in an electric panel. The entire station itself could be decoupled, and there are some methods to use for that and schematics that we could help with to install that properly. Thanks again for coming to the Dairyland website and learning just a little more about decouplers and how to use them, and a little more about Dairyland itself.